In this lesson, we are going to carry out some calculations to determine the minimum value of RS for a supply that varies between 20 to 24 volts and for a maximum load of 500 milliamps. So here you see the requirements: VS 20 to 24 volts, VZ 12 volts, IL maximum 500 milliamps, and we are required to calculate the minimum value for RS for the circuit to function correctly. So first of all, we will draw the circuit. Right, so we're going to draw circuit. VS 20 to 24 volts, RS VZ 12 volts, RL with an IL maximum, IRL max of 500 milliamps. Okay? The next step is to write the required equation, and the required equation is RS max is equal to VS min, the minimum voltage of the supply, minus the Zener diode voltage divided by IL max. Okay? Right. Okay, let's continue. RS max is equal to VS min. VS min is 20 volts minus VZ is 12 volts, Zener diode voltage, divided by 500 milliamps or 0.5 amps. That gives 8 volts divided by 0.5 amps equals to 16 ohms. So your RS value is 16 ohm for this circuit. Now we are going to check for correct operation of the circuit using the Thevenin method, finding the Thevenin voltage across the Zener diode. Remember, for correct operation, the voltage, the Thevenin voltage across the Zener diode must be at least equals to the Zener voltage, which in this case is 12 volts. So first of all, we need to calculate the load resistance for a maximum current of 500 milliamps. We're going to use Ohm's law to make this calculation. RL would be equals to VZ divided by IL max, which is equals to 12 volts divided by 0.5 amps, which is equal to 24 ohms. Okay, so that will be the value of the load resistance. Now we're going to use Thevenin voltage method check using the minimum voltage of the supply. So the Thevenin voltage across the Zener diode would be 20 volts multiplied by the load resistance 24 ohms divided by the series resistor, which is 16 ohms, plus the load resistor 24 ohms. That equals 24 divided by 40, of course, times the 20 volts, and that gives us If you work that out, you will see that that equals to 12 volts, which is exactly equals to the Zener diode voltage. So this circuit should operate at the extreme condition of a minimum voltage of 20 volts input and a maximum load of 500 milliamps or 0.5 of an amp. Next, we will check for correct operation if the input supply goes up to 24 volts. So again, we will use the Thevenin voltage method to check for this. So, following the previous example, now the VThevenin, VTH across the diode, would now be equals to 24 volts multiplied by the load resistance value divided by the sum of the load resistance and the series resistance, which we found out to be 40 ohms, and that works out at 14.4 volts, which is well above the 12 volts required. So the circuit will work for an input voltage of 24 volts, which gives a Thevenin voltage of 14.4 volts across the Zener diode.